So in the last lecture, we took a look at some rational functions and thought about how to figure out where their vertical asymptotes are. Well, in this lecture, we're going to go the other way. And we're going to think about how to tell where a rational function has a horizontal asymptote. Right? That's a horizontal line that the graph gets closer and closer to, right? But for extreme values of x, right, for really big values, it never crosses it. So to do that, we're going to look at some examples. And this situation is a little more complicated. There's actually 3 different possibilities. And to illustrate those, I'm going to use the same approach that we took with vertical asymptotes and just calculate some points. Right? And you notice I'm picking really big x values here. Right? I'm letting the x values get really large because it's out of the edges that we're thinking about, do these horizontal asymptotes exist? So I would encourage you to pause the presentation, go ahead and do this calculation for yourself, right? Put the x values I've picked out here into each function and see if you can see a trend. Right? See if you can see what's going on as those x values get large. So with this first function here, 3 over x plus 1, if we put these numbers in, we get 0.2727, 0.0297, 0.003, and then 0.0003. So the trend here is that these numbers are getting smaller and smaller and smaller. More specifically, they're getting closer and closer to 0. But, and you can confirm this for yourself pretty easily, the function is never going to equal 0. You can see that by taking the function and setting it equal to that, right? Do 3 over x plus 1 equals 0. Try to solve that equation. You're going to see there is no solution. There is no x value that's going to give you 0 for a y value. Okay, so we've got one trend here. Now let's take a look at this one. The middle one, 3x plus 2 over x plus 1. If you do these substitutions here, something different's happening. You get 2.9091, 2.9901, 2.9990, 2.99999. So if you look at these, the first one, 2.9091, that's kind of close to 3. 2.99, that's even closer to 3. 2.999, closer still, and so on, right? So the function values appear to be getting really close to 3. And again, you can test that it's never going to get there. Set 3x plus 2 over x plus 1 equal to 3. Try to solve that equation. You're not going to get an x value that works. Okay, so the horizontal asymptote here appears to be at y equals 3. Okay, 2 cases, 2 different numbers. How about this next one? Right. Now here we get a completely different behavior. 10 gives me 27 something. 100 gives me 297 something. 100, 2,997. 10,000 is 29,997. These numbers just get huge, right? There doesn't seem to be an upper limit to where these numbers are going, and that would be correct, right? We'll see in a minute that function, in fact, does not have a horizontal asymptote. Okay, so how can we classify these things, right? How can we come up with a rule here? Well, the rule is going to be based on the degree of the numerator versus the degree of the denominator. Remember, we're talking about a polynomial with one variable, like everything we've got going on here. The degree is just the biggest exponent. So looking at the f of x function here, the degree of the numerator is 0. There is no x up there. The degree of the denominator is 1. Okay, if we do it with the g of x, here both degrees are 1. They're the same. And if we look at h of x, the numerator is 2 and the denominator is 1. Okay. So hopefully you're kind of starting to figure out what the rule is going to be here. Right? For the first case, if the degree of the numerator is less than the degree of the denominator, okay, the denominator is bigger, then there's a horizontal asymptote of y equals 0. That's the end of the conversation. Right? And that's what we saw happening here with our numbers. So if we look at the third case, I'm going to skip. The g of x one is a little weird. So let's jump and look at h of x. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Again, you can move on to whatever your next step is. Now, this middle case, this one is a little interesting. In this case, I'm saying that the horizontal asymptote occurs at ratio, right? Well, what ratio? It's the ratio of the leading coefficients. Right? The leading coefficient of 3x plus 2 is 3. The leading coefficient of x plus 1 is 1. And the horizontal asymptote occurs at y equals 3 over 1, which is just 3, right? Which is what we were seeing here with our numbers. Okay, so let's look at some examples. So I have a rational function here, and I want to figure out if it has a horizontal asymptote, and if it does, what is it? So our rules say look at the degrees, right, and compare them. So the degree of the numerator is 2. The degree of the denominator is 2. They're the same. So because they're the same, I'm going to look at the leading coefficients. So the leading coefficient of the numerator is 4. The leading coefficient of the denominator is 7. That tells me where the horizontal asymptote is. It's at y equals 4/7. And that really is all there is to it. Right? Now, at this point, you may be thinking to yourself, okay, can there be more than one? Right? Can there be more than one horizontal asymptote? Because there can certainly be more than one vertical one. I mean, the denominator could be 0 at more than one place, so there could be lots of vertical ones. The answer to that, in general, is yes. It is possible. It's not possible with rational functions, like the ones we're going to be talking about here. All right, rational functions can have at most one horizontal asymptote. So how about this thing? Does this have a horizontal asymptote? Well, again, we're looking at the degrees. The degree of the numerator is 1. The degree of the denominator is 2. The denominator is bigger, so this graph is going to have a horizontal asymptote at y equals 0. And it really is that simple, right? Compare the degrees. There's our answer. Okay, so how about this one? One more example. Here, the degree of the numerator is 3. The degree of the denominator is 2. The numerator is bigger, right? And in the case where the numerator is bigger, there is no horizontal asymptote. And again, that's it, right? That's all we need to do to get our answer. Okay, so yeah, this one is a little more complicated, right? You've got 3 cases you've got to remember. But I don't think it's too complicated, right? I've talked about this in a number of places, right? Get an index card, right? Write the rule on it, have the rule in front of you for a quick reference, and you do a lot of practice problems. You'd be surprised how quickly you're going to end up not needing that reference card anymore. So looking ahead, right, we're going to continue adding tools to our toolbox. Right? That really is our goal here. Add a bunch of tools that we can use to describe the behavior of a rational function with the ultimate goal of being able to sketch the graph of one.